Hello. Uh, that- so hi everyone. I am Aditi Pandit, and I'm an engineer at IBM. And I'll be talking about Prestissimo efforts at IBM for last year. So the last time we presented in VeloxCon, that was a year ago, we presented as Ahana, and we were a startup that had an offering for Presto and Prestissimo. It was a managed service on S3, and the use cases were around open data lakehouse. So we had put a lot of effort into Parquet, Iceberg, other table formats. And so IBM Data and AI group kind of had a lot of interest in this offering, and we got acquired soon after. And so now we are part of IBM Data and AI org, working on watsonx data specifically. I will start the presentation with some overview of what are the main components of watsonx and how Prestissimo falls in the watsonx data architecture. And then the rest of the presentation will be about all the activity in Prestissimo over the last year. Towards the end, we'll talk about what we're calling like Presto 2.0. And that is a lot about making the native engine the first class engine in Presto. And it's kind of about getting the whole Presto ecosystem tightly coupled with the native engine. So to start with, watsonx is IBM's enterprise data and AI platform. It's a product that came out last year. And so there are many parts of watsonx, but the three core foundation components of watsonx are watsonx AI, watsonx data, and watsonx governance. So watsonx AI, very quickly, like summarizing what these three are about. watsonx AI is a studio for building AI pipelines. It has a library of models. There's Lava 2 from Facebook, and like IBM has its own like Granite models, in addition to many other open source models that are there in the industry right now. And with watsonx AI, you can it has a lot of components to actually do like it's got a data refinery tool to identify features in your data that might be interesting for building AI pipelines, and it has ability to like automate and deploy AI pipelines, and there's stuff for doing a prompt lab in order to be able to build bots and the like. watsonx.data, we'll talk a lot more about in subsequent slides. And the last component is watsonx governance. And watsonx governance gives enterprises a means to track their AI pipelines through their whole life cycle. And a lot of the technology is in providing enterprises means to look at parameters like the bias and fairness in the models and track it over time, basically identify drift and kind of build all the reporting and dashboarding that's needed for regulatory and compliance needs. Prestissimo is a key part of watsonx data, which sort of is the open data lakehouse that works with all the rest of the components. So it is used for a lot of AI stuff and more conventional like reporting needs, analytic workloads. So in terms of like the open data lakehouse like architecture, right? There are multiple tiers. So on the left-hand side is a diagram showing all the tiers in the data lakehouse environment. So at the bottommost are the infrastructure tiers, and I kind of wanted to point out that IBM is very big on the notion of hybrid and multi-cloud deployments. And so we look at data sets that are pretty much, they could be on-prem, they could be in IBM cloud, but even in all other public clouds like S3 and GCS and Azure. And the infrastructure, so these engines also work on-prem, pretty much any cloud, and they're like different deployment models for how users set up clusters. And but coming to like the main lake house, the lake house comprises of like the data, the actual data sets, the query engines, and like the metadata and governance around it. So your data sets, we kind of so this is an open data lakehouse offering. Data sets are in open data formats, and that is very intentional because these are vendor agnostic, they can be shared across engines. So I mean, you could have the data ingested via Spark and then queried via Presto in an ideal world. That's where open formats come in. We're focused on Parquet and Iceberg to start off with. And at the topmost layer are like the data engines that can be configured in the lakehouse to actually run SQL queries. And so Presto and Spark are two of the big engines in lakehouse, but watsonx.data also supports the traditional IBM engines like DB2 and Netezza. So these screenshots kind of show how like different engineers interact with watsonx.data. So in terms of configuring your infrastructure, there's a tool called Infrastructure Manager. And the engineers lay out like the data sets, the catalogs, and the engines. So like at the lowest layer are the data sets. So as you can see, this is a data lake. So we have like the data set sitting in open data lake formats, and then you have on the right-hand side the proprietary DB2 Netezza data sets. So on the left-hand side, you have Parquet, Hoodie, and Iceberg sitting in IBM Cloud and other places. So these data sets are exposed via catalogs to the query engines. And so as you can see here, that every data set comes through a catalog, and a catalog is kind of backed by a metadata service. There's Hive typically right now, so the Hive, Hoodie, Iceberg data, and DB2 Netezza data are exposed via these catalogs to the engines. And at the topmost layer is the engine, and I want to emphasize on Presto, which is like the last engine. And Presto, because of its federated architecture, can pretty much go against all the file formats and table formats and the different systems you see out here. And so that plays in very well with the open architectures that we're focused on. So I think the one thing that's missing is how are people configuring it, and there's a lot of flexibility in that. The second tool is the query workspace, and this is what data engineers use to interact with the data in the lakehouse. And so on the left-hand side, you can see all the catalogs and look at the tables. And because the Presto is now integrated with IBM's knowledge catalog, that kind of gives you a lot of attributes that for these data sets, and allows you to do like semantic searches to find data sets that match your needs. And you can choose the engines and run your queries. So you have like one tool in which you can choose whichever engine you have in mind, run your queries, look at the results, and build worksheets. So again, I want to emphasize that IBM focuses a lot on the next-gen hybrid multi-cloud platform. Red Hat is a part of IBM, and a lot of this is powered by using the OpenShift technology. And we support pretty much all the clouds and on-premise. And HANA came with like a bring your own cloud option, and we're going to support that as well. So that's that about what's next and where Prestissimo fits in. Um, Prestissimo, just to summarize in 2 slides what it is, it's a drop-in replacement for the Presto Java worker, and it is a native engine written in C++. It has the same control interface and data interface as the Java worker. And so you have the Presto Java coordinator that figures out all the distributed execution aspect of the system, but it's the Prestissimo native worker that actually does the data movement following the same control API that has been part of Presto. Prestissimo is a C++ worker. It's built over Velox. And so we get all the nice features from Velox, heavy use of SIMD, adaptive runtime optimizations, smart IO, prefetching, caching, and new memory arbitration features. Again, why are we doing all this? Of course, a huge performance boost. We see that we can run the same queries with much smaller clusters, and so this has given a very good price performance story. Because there's no Java processes, no JVM, no garbage collection, and all the memory management is under explicit control in C++. It gives us a lot of insight into the operations and a lot of control in how we want to build policies and everything around setting up workloads. Velox also comes with memory arbitration that helps run bigger queries in smaller memory footprint and improves efficiency. And again, because Velox is extensible and reused across multiple engines, it brings in a certain engineering efficiency, because these primitives are built by many engineers who have a common understanding of how data is transformed, and performance and operations are better understood across these teams. Okay, so last year, after we got acquired, we came into IBM, and one of the first things we had to do was to inner source all this into IBM watsonx and the IBM tech stack. And this has meant going through all the security audits and integrating with the knowledge catalog, and basically building all the operators and to work with OpenShift and kind of make this available in all the form factors to different people. And so we now have a lot more, this kind of got done last year, and so we have tons of teams and many engineers who are working with us right now. And there's the dev team, DevOps, testing, docs, research, both database and storage research, and hopefully sales and solution engineers in the future. And the second goal was to build a solid Presto OSS team at IBM. So this includes HANA engineers, and we have a whole lot of engineers from IBM who joined us. And I'm going to talk mainly about what's happened in OSS with this team in the last year. So okay, one of the first things we had to do is kind of define what will be an MVP for Prestissimo on watsonx. And the focus was on defining this MVP and being able to build and operationalize this. We focused on, so in order to be able to do demos, you really need CTAS. And so one of the things we need to get in place was being able to do CTAS, creatable as select. And this needed S3 support, and we started with Parquet, reader writer. And so those are the first components we try to complete. And we kind of worked on SQL coverage, so getting pretty much all parts of the SQL query to work. And so looking at parity between Presto Java, we got all the data processing operators. We kind of worked on completing the functionality there. And types and functions coverage. We're pretty close, I think, in terms of the basic functions. Around 80–85% of them are done. and there's a whole lot of testing going on right now. From a security perspective, we added support for JWT and shard-based TLS, transport layer security support. And so when we are looking, so I mean, in terms of like building this, there's also a whole quality aspect to it. And so one of the first things we kind of wanted to do was in terms of like thinking about like what could be useful for the open source. We took like what are Presto tests, and that's pretty much all the unit tests that run for Presto Java, and kind of got them operational with the native engine. And that kind of, the idea was that this will help us assess what parity looks like. Because, I mean, eventually we want to kind of be able to do whatever the Java engine is doing. And so these are a lot of the test suites that we kind of worked on. And this has reached a point where we can, we have the pipelines to run this for every Presto build. So if you see, there are about like 1,700 test cases with like, so the number of SQL in this is like, I know maybe a few tens of thousands. And many of these test cases kind of had to be rewritten because they're like different error messages and whatnot. We opened like 33 bugs, closed 11. So those are the most important bugs, in our opinion, P0s, because they're like correctness issues. But I mean, this was a really good contribution from our side. In 2024, we continued on this theme to get Open Takehouse features, and so the component that had a lot of work was done is the Iceberg reader, and there's also a lot of emphasis on Prestissimo production readiness. So the first thing was to be able. So we kind of worked on metrics collection and with open source technology like Prometheus, so that we can build dashboards and make this available in IBM and in the community as well. And Velox as a system has very different implementations. So there are new components like the async data cache, spilling, memory arbitration that have come into the picture. And what we've been doing is doing benchmark runs, both with TPC-DS, TPC-DS. We got a bunch of IBM customer workloads also that we have operationalized in our pipelines. And the way we approach it is we first, and so because it's a flexible platform, right, we have as many options in order to be able to set clusters. And so what we do is first try to find the configuration where we get a very predictable runtime for the benchmark workload, and then start playing with constraining that cluster to see how it stands up. And so the TPC-DS benchmarks have been getting a lot of attention across multiple parties. And so we're doing like 1K, 10K, and even bigger numbers, 30K, 100K, going with that theme. Yeah, I really want to call out to the entire team, because there are many, many optimizations that kind of are being done very actively. And so this project moves very fast, and going from week to week, we see these numbers getting better and more predictable, which is sort of super nice. In order to get there, I mean, in terms of IBM also had to do a lot in terms of having a performance testing and tracking framework to kind of see that we get repeatable numbers. We built a pbench tool which automates deployments, lets you choose workloads and run them, and captures all the metrics. There's a performance dashboards, plan comparison tool, and yeah, we will open source all these to help other teams. But yeah, in terms of TPC-DS numbers, this is like totally on open source Presto, and this is like 287. So that's pretty much like last week. And in terms of 1K, we ran this on a cluster with like 8 workers. So this is on AWS with our 5.4x large machines, 1 terabyte of memory. And so the blue lines are Presto Java. So this is a Java versus native comparison. The blue lines are Presto Java, and the red line is Prestissimo. So as you can see, the Prestissimo run completed in 33.6 minutes. In Java is like 1.15 hours. So this is like a summation of the query durations. It's like the wall time. Um, so yeah, this is looking good, like maybe 2.5x right now. And I mean, the outlier is like 67. That's a known bad plan, but that's how it is. 10K, this is also a very recent run as of last weekend. This is a slightly bigger cluster with 16 workers, a similar machine configuration, and 4 terabytes of memory. So native completed in 1.6 hours, Java in 2.83. Again, like 67 is the outlier, but the blue line is Java, red is Prestissimo. So we see like improvements across the board. So in terms of what are top issues, so Velox is very memory hungry. And so like those previous clusters, they are provisioned intentionally with pretty big memory configuration so that everything runs in memory. This is a power run, so we're just running one query at a time. But in general, Velox is very memory hungry. There's a lot of tuning we kind of had to do to get to the point where the benchmark runs are consistent. So there's some issues there that we're kind of trying to work through. You can follow discussions in this issue. But after kind of tuning that out, looking at the topmost operators in terms of the time and CPU usage, I think Exchange is still out there. And I think I called it out because Java exchanges did better than Prestissimo. So like maybe there's some optimizations there that we can have to look at. And HashProbe is also pretty big in terms of the amount of time it's taking. And so, but I think we understand what's going on there because these data sets are, they have like a lot of, they have multiple matches on keys. And so like we think that the hash table and join. Yeah, so that's where we are right now. And I want to end kind of trying to get people on board with us for what we're calling Presto 2.0. And the intent is to make like the native engine the first class engine in Presto so that we don't have this. So we are able to migrate. So I mean, we don't have a migration problem like Meta, but we still need to have a product that has both Presto Java and Prestissimo till Prestissimo catches up with Presto Java. And so we don't want that gap to be running with that gap for a long time because that will just make it harder. And I mean, we need a good story to sell Prestissimo. So the themes that we're going to work on. So the first gets a lot of attention, the native engine, SQL feature completeness, production readiness, performance improvements. Where IBM contributes a lot is the lakehouse formats. So we've done Iceberg, we're going to do Iceberg Writer as well this year. There's interest in the community on Hoodie. And the big gap to close this Presto Java, Prestissimo parity is the connector SPI. So a big advantage of Presto in the data lakehouse was this ability to go against all the different data sets sitting on like the different databases and systems, right? And so to get there, we have to have an SPI for Prestissimo, and this needs to work for people writing UDS, UDAs, connectors. So that's a big gap that we're trying to fill. And all this also has to play in well with the optimizer. So I mean, with Prestissimo, we get like opportunities for new, like physical plans. And so we would like to enhance the optimizer to be able to get there. And so some of these things, so we kind of looked at the Presto optimizer, identified a bunch of things that where the gaps are, and so some of these are more conventional, like opening up the search space and cardinality estimation. But maybe we'll need to fix some of the gaps there to be able to leverage Prestissimo. Yeah, so acknowledging the team. So we have the HANA engineers and a whole lot of people from IBM joined us. So thanks to the team and everything that you do. It's great that we have so many new pairs of eyes looking at Prestissimo. And yeah, please join our community. This team is a very Presto OSS focused group and is very active in the community. Join the working groups. There are a bunch of working groups for the native engine, architecture, optimizer, and a lot of activity on GitHub, Slack. People usually respond very quickly. So yeah, definitely join our community.
So this is a watsonx.data question, not with Velox. So does the watsonx.data platform support like bring your own query engine, bring your own compute, or does it have to go through the bundled Spark Presto?
I think right now you have to go through the bundled. So because we built like the containers and the primitive, the operators using like OpenShift, and like those are kind of getting deployed on whatever configuration you're choosing, whether that's going to be on premise or in the cloud or like your own cloud. So even if you come with your own cloud, we are actually going to deploy the bundled version.